Okay, so reductions of numerical values today, and I want to quickly take you back to your special angles from grade 10. If you remember your special angle triangles, I've drawn the 45-degree triangle, the little one, and this bigger one is a 30 and 60 triangle. Okay, so with the 45-degree triangle, we had sides of 1, 1, and 2. And for the 45, this side here is the adjacent. This side here is the opposite, and the hypotenuse is a root 2. In your 30-60 triangle, remember we had sides of 1, root 3, and 2. If you use Pythagoras, you can find those sides. And for 60, I've used an orange color here. This is the adjacent. That is the opposite, and obviously this one stays the hypotenuse for both the angles, the 2. For the green, the 30 degrees, remember you swap, and the root 3 becomes the adjacent, and the 1 becomes the opposite. Remember, the adjacent side always touches the angle that you're talking about. So that adjacent side touches the 30. If you're using 60, then this would be the adjacent side. And then the hypotenuse, you should all be able to find, is opposite the right angle. If we look at our SOHCAHTOA, so sine is opposite over hypotenuse, cos adjacent over hypotenuse, and tan is opposite over adjacent, we can read off any values for special angles without using our calculator. So if I said to you, what is the sine of 60? You would say, okay, well, the sine of 60, I'd have to use, obviously, the 60-30 triangle, and it's opposite over hypotenuse for sine. And for 60, the opposite is a root 3, and the hypotenuse is a 2. So we wrote root 3 over 2. If we said, what is a tan of 30? Okay, so tan of 30. Tan of 30. 30 is a green angle here. Tan is opposite over adjacent. TOA, opposite over adjacent. So tan of 30, opposite would be 1, and adjacent would be root 3. So we use these triangles to read off the special angles, which you did last year. What is the sine of 45? Okay, sine 45. Obviously now I have to change my triangle and use a 45-degree triangle. Sine is opposite over hypotenuse. For 45, opposite is 1, and hypotenuse is root 2. All right, so you need to remember your triangles. Okay, so in a class diagram, we always do numerical reductions with the 180 minus theta, the 180 plus theta, and the 360 minus theta. So here's our class diagram, just to remind you. This is 0, 90, 180, 270, 360, or sine is positive here, tan is positive here, and this is 180 plus theta, and cos is positive here, and this is 360 minus theta. So these are the ones we use for numerical reductions. Okay, now how do you know which quadrant an angle is in? Well, if it's between 0 and 90, it's in the first quadrant. If it's between 90 and 180, it's in the second quadrant. If it's between 180 and 270, it's in the third quadrant. And if it's between 270 and 360, it's in the fourth quadrant. So it's easy to work out where it is because you've got the size of it. All right, so whenever we do these, we always have a little mantra that we say to ourselves. We reduce, we replace, and we simplify. RRS. Reduce, replace, simplify. All right, so first, to reduce, we have to say which quadrant is this angle in. And this angle between it's bigger than 180. Look, it's 240, so it's between 180 and 270, so it's in the third quadrant. Okay, so which quadrant is it in? Third quadrant. Okay, then we write it using the 180s, the 360s. So we've got to write it using what we have in that quadrant, 180 plus theta. So what we do is we write the 240, it says 180, so 180 plus, because it's a third quadrant angle, it's going to have to be plus 60, because 180 plus 60 gives me 240. So you have to rewrite it using either the 180 minus, 180 plus, or the 360 minus. It's got to be one of those that we use. And if it's third quadrant, it has to be 180 plus. Okay, once you've rewritten it, you're going to reduce it. Okay, so we're going to work out our sine and reduce it. Okay, so sine in the third is negative. So we go negative sine and we reduce it to the acute angle, the 60 there. Right, and now once we've reduced it, we can replace. So it's a special angle, so we want the sine of 60. Sine of 60 is opposite over hypotenuse, so we go back to our special angle triangles. Sine of 60, opposite over hypotenuse, so it's going to be root 3, opposite over 2. So we finish it off by going negative root 3 over 2. So sine of 60 is root 3 over 2, and this negative sign stays in front there. All right, let's try the next one. Right, so first of all, which quadrants are we working in? So this is 330, that's between 0 and 270 and 360, so that's the fourth quadrant. Tan 135, well, it's bigger than 90, but smaller than 180, so it's in the second quadrant. If you look on the diagram, in the fourth quadrant, you have 360 minus theta. And in the second quadrant, you have 180 minus theta. So those are the things we have to use to reduce them. Okay, so let's see. Cos, now I have to write 360 minus what gives me 330. So 360 minus 30 will give me 330. Tan 135, so at the bottom, tan, it's got 180 minus theta, so 180 minus what gives me 135, and it's going to be 45. So this is just rewriting them. This still equals 330, this still equals 135. All right, now we can go and we can use our signs. So cos in the fourth is positive, and we're going to reduce it to that 30 there. And tan in the second is negative. Okay, so now we're doing our sine and reduce. And then finally we're going to replace them from our special angle triangles. Okay, so let's see. Cos of 30. Okay, cos is adjacent over hypotenuse. So cos of 30 Adjacent for 30 is root 3. Hypotenuse is 2. So this is positive root 3 over 2. And the tan of 45, remember we've got a negative as well. We mustn't forget our sign. Tan 45, opposite over adjacent for tan. So for 45, it'll be 1 over 1. Okay, so we've got root 3 over 2 over negative 1. Positive over a negative gives me a negative root 3 over 2. Okay, so we've got identify the quadrants, rewrite them, do your sign and reduce it, replace your special angles, and then simplify it at the end. So we need to add here, simplify. Okay. All right, let me just write all these rules down the side here. So 1, identify quadrant. 2, rewrite. 3, do your sign and reduce. 4, replace. And 5, simplify. Okay, so remember we spoke about these squares as well. So I'm looking at the square here. Remember the squares go on the outside. So you use it on the outside of your bracket. Okay. So identify the quadrant. 315 is in the fourth quadrant. It's between 270 and 360. So this is a fourth quadrant angle. 210, well, 210 is between 180 and 270. So this is a third quadrant angle. So I've identified the quadrants. Now I need to rewrite them. Okay, so fourth quadrant says 360 minus theta. And third quadrant says 180 plus theta. So that's how I have to rewrite them. All right, so let's do the rewriting. So I've got the sine squared of 360 minus what? 45. That gives you 315. Don't forget the minus 1 at the end there. Sine squared 210. Well, we said that 210, third quadrant, 180 plus what? 180 plus 30. Okay, so there's my rewriting. Now we're going to do the sine and reduce. Okay, so now we need to put this in a bracket. So this is going to be, we said this one's fourth, hey? And this one's third. Sorry. Okay, so sine in the fourth is negative. So it's negative sine 45 squared. You reduce your acute angle, minus 1. And at the bottom, sine in the third is also negative sine 30 squared. Okay, replace. Are they special angles? All right, sine of 45. I'm just going to do this here. Sine of 45 is opposite over hypotenuse. So we're going to have negative 1 over root 2 squared minus 1. And that's going to be over negative sine squared of 30. Here's your triangle. Here's your 30 up here. 1 to root 3. So the sine of 30 is opposite over hypotenuse. So it's going to be 1 over 2 squared. Don't forget your squares. Okay, so we've replaced them, and now we're going to simplify using our algebra. So we're going to have, when we square, remember we square the sine, we square the top, and we square the bottom because it's one term. So that's got to go to all of those, hey? Same at the bottom. So we've got a positive, 1 squared is 1, root 2 squared is 2, minus 1. And that's going to be a positive 1 over 4. Okay, square the top, square the bottom, square the sine. And then we're going to finish off a half minus 1. You can either get a common denominator, or you can tell me that that is negative a half over a quarter. And then we change division to multiplication, invert the fraction at the bottom, multiply top with top and bottom with bottom, which gives you negative 2 as my answer. So my simplification is purely arithmetic there. Add a page. Okay, let's try one more. Let's try tan 240. Tan negative 30. Sine 240. Cos squared 135. Okay, so do we know what quadrants we're in? Can we see that? Yes, we can. This is quadrant. Okay, so 240 is between 180 and 270, so that's a third quadrant angle. So this one must also be a third quadrant angle. Tan of negative 30, well, we can't see what quadrant this one is in. It's not between 0 and 360. So if you remember, we said we were allowed to add or subtract 360 and it wouldn't change anything. So I can do that. And here I can see that this is in the second quadrant between 90 and 180. Okay, so I need to fix the one that I can't see the quadrant for. So tan 240, sine 240. This is going to be tan of 330. Now I can see which quadrant it's in. 360 plus 30 gives me 330. Okay, so now I can see that this one is in the fourth quadrant. So this is 3, 3. And remember, quadrant 3 says 180 plus 180 plus. This is quadrant 4. Quadrant 4 says 360 minus. And quadrant 2 says 180 minus. Okay. All right, so tan of 240, we're going to rewrite. Tan of 180 plus what? 60. That gives me my 240. Sine, also 180 plus because it's third quadrant, so 180 plus 60. Tan of 330. For quadrant 4 says 360 minus what? So 360 minus 30 would give me 330. And this would be cos squared 180 minus 45. Okay, so I've rewritten those. And here I've identified the quadrant. Okay, now we're going to reduce and check what sign they have in that quadrant. Okay, so tan in the third is positive, and we reduce it to the acute angle. Sine in the third is negative, and we reduce it to the acute angle. Tan in the fourth is negative, and we reduce it to the acute angle. And this, remember, it's squared. Cos in the second is negative cos. Reduce it to the acute angle, and we're going to square it. Okay, now we need our replace. And in this case, they're all special angles. Okay, so tan of 60, 60 opposite over adjacent. So this is going to be root 3 over 1. And this is negative sine 60, opposite over hypotenuse. So 1 over 2. What have I got at the bottom? I've got negative tan of 30, opposite 1, adjacent root 3. And then we have negative cos of 45, adjacent over hypotenuse squared. Okay, and we're going to finish with our simplification. Okay, with algebra, or in this case really arithmetic. All right, so at the top, multiply fractions. Positive times a negative is a negative. Root 3 times 1 is root 3. And 1 times 2 gives me a 2. At the bottom, I need to do the square, so let's leave this one. And let's take one term, so we take square that, and square that. So we're going to have a positive 1 over root 2 squared is 2. Okay, so there's the top. Need to finish by multiplying the bottom. Negative times a positive is a negative. 1 times 1 is 1. And this is 2 times root 3. And then we're going to change our multiplication. Our division, sorry. This is a division sign. We're going to change it into multiplication. So this will become inverted, remember? 2 root 3 over 1. And don't forget it's a negative. All right, so negative times a negative is a positive. 1, there's a 1 in front there. Hey? Let me just make it a... One times 2 gives me a 2. Root 3 times root 3 gives me a 3. Okay, so you've got 2 times 3 at the top, and you've got 1 times 2 at the bottom. Okay, so that's going to give you 6 over 2, and the answer is going to be equal to 3. If these fractions are a problem, then it's kind of acceptable to help yourself with your calculator, but best case scenario would be obviously to try and do it without a calculator. It's going to help you in the long run when you have to write your MBTs. All right.